polynomial is defined by p of z is z to the 4 plus az cubed plus bz squared plus 63z minus 52. It is known that z equals 1 and z equals 3 plus 2i are both zeros for p of z. Find the values for a and b. So I'm going to look at this by two different methods. The first method is that we know that p of z has 4 zeros because it's a z to the power 4. Now z equals 1 is a 0. That means z minus 1 is a factor. Also, z take away 3 plus 2i is a factor. Because we know that any complex roots occur as conjugate pairs, z take away 3 minus 2i must also be a factor. Now this is a 1z to the 4, so if we have another factor, it must be a real factor because any complex ones occur as conjugate pairs, so we'd need two of them if we have one of them. And clearly there's no space for that because we have a real one over here, so let's call it z minus d. So what we can do with this d is let's consider the negative 52. So negative 52 must be equal to, so that's going to be the constant term, so this times this times this times this, negative, 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 so it's going to be positive, and then we're going to have 1 times 3 plus 2i, then 3 minus 2i, and then d. So negative 52 is going to be 9 add 4 is 13, 13d, telling us that d is negative 4. So we now have that p of z is z minus 1, z minus 3 plus 2i, z minus 3 minus 2i, and z plus 4. Now, to take the sting out of some of this algebra here, we could just use the calculator, so we're going to need to be in complex mode, and action, transformation, and expand. So what do we got? I'm going to put x minus 1. Then we're going to have x take away, and it's going to be 3 plus 2i, so 3 plus 2, and we need the correct I, which is this one here. And then we'll have x take away 3 minus 2i, and finally x plus 4. And if we expand that, we get this, and therefore we can see by looking at these two terms, the cube term and the z squared term, that a is equal to negative 3 and b is equal to negative 9. So an alternative solution is that we know that p of 1 is equal to 0. Substitute that in and we've got 1 plus a plus b plus 63 take away 52 is equal to 0. So that gives me a plus b is negative 12. Call that equation 1. We also know that p of 3 plus 2i is equal to 0. Now, let's look at the bits here that don't have the A and the B. So what are we going to have is, so what we want to do is expand. So we're going to have, to start with, 3 plus 2i. I'm just going to make a copy of that. So let's just copy that. And that's going to be to the power 4. And then we've got add 63. And then we'll paste there. And then we've got minus 52. So all of that gives us 18 plus 246i. So 18 plus 246i. And then if we look at these two terms here, so we've got a into, and what we need to do is expand this one cubed. So that's negative 9 add 46i, and then b, that's going to be in expand this one squared this time, 5 plus 12i. So we get negative 9 add 46i a, add 5 plus 12i b is equal to negative 18 take away 246i, and we'll call that one equation 2. And then we can solve that on the calculator. So let's just clear off for a second. And we need the simultaneous equation solver, which is here. So I'm going to put in x add y equals negative 12. And then I'm going to put in negative 9 add 46i x's, and 5 add 12i times y is equal to negative 18 take away 246i. And we're solving that for x and y. So execute that. X is negative 3, y is negative 9. So the x was the a, and the y was the b. Express cis 5 pi by 2 in exact Cartesian form. So let's think about where it is. So pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2. So it's up here. The modulus is clearly 1, and so it's the same as this pi by 2, so it's just I. Given that cis 3 theta is equal to cis pi by 2, determine the 3 possible exact values for cis theta in Cartesian form. So what we can do here is we can say that 3 theta is pi by 2 plus 2n pi, where n is an integer. So theta is going to be pi by 6 plus 2n pi by 3. So n equals 0 gives theta is pi by 6. N equals 1 gives that theta is pi by 6 plus 2 pi by 3. So that's pi by 6 add 4 pi by 3, which is 5 pi by 2. N equals negative 1 would give that theta is pi by 6 take away 2 pi by 3. So that's pi by 6 take away 4 pi by 6. So that's negative 3 pi by 6, which is negative pi by 2. Now, we wanted Cartesian form. So, cis pi by 6 is equal to cos pi by 6 plus I sine pi by 6, which is root 3 over 2 plus a half I. Cis of 5 pi by 6, we know that the cosine will have a different sign, but the sign will be the same. And then cis of negative pi by 2 is just minus I.